question was already done yesterday, right? But because we could not come to this part, so we are redoing it. So the question is how many elements of the words daughter are placed with this given condition. The first condition is the vowels are together. No? So since we want the vowels together, we will first of all segregate the vowel from the consonant. And the vowels used in this daughter word is A, U, and E. And the remaining letters are
C, G, H, I, R.
Okay. So, since we want all the vowels to be together, we will keep it together in a box, right? Or maybe we will tie it together and we will represent it by a single letter, X. Now, when we arrange these 6 letters, one this letter and then the other 5 letters, when we arrange them, wherever you take this X, wherever you keep this X, all the 3 letters will go together.
Yes, sir.
So, in how many different ways we can arrange this? So that the vowels come together is because there are total how many letters? 1, 2, 3, 4, 5, 6. So first of all, we can arrange these 6 letters in factorial 6 ways. Is it okay?
Yes, sir.
And after that, you are taking this X as it is. But inside, because there are 3 elements, and these 3 elements right now it is in the order of A, U, E. But there is no fixed order of writing these 3 letters. We can have this letter 3 letters in any order.
Yes, sir.
This can be again rearranged among themselves. We can write this in any way we want, right? So since there are 3 letters, we can further rearrange these 3 letters in factorial 3 ways, and therefore the total number of ways in which we can arrange or keeping all the vowels together will be factorial 6 and into factorial 3. This is very clear, no?
Yes, sir.
Another part of this question is the vowels are never together. If you have any such question, because you have already calculated the vowels together, and now you want just opposite of that. No? Whenever we do so, we will always go through subtraction. What we need is, we need to remove this many number of ways. From the total number of ways, you will get the answer of your next question. No? Where the vowels are never together. Because we have already calculated the number of words in which we will have the vowels together.
Yes, sir.
And if we can remove that many number, from the total number of ways, we will get the number of times where the vowels are never together. Isn't it?
Yes,
So, to do this, we need to know what is the total number of ways now. Right?
Yes.
And that we can get from the letters used in the word daughter. Is it alright?
Yes, sir.
So, there are total how many letters in this word?
8.
8 letters. So the total number of ways in which all the letters can be arranged is factorial 8. Out of which we are going to eliminate when the vowels are together. So that we can get the answer for vowels not being together. Is this clear?
Yes,
So the answer of this question can be factorial 8 minus factorial 6 into factorial 3. Yesterday I already explained you how to solve it.
Yes,
In place of expanding each of the factorial, you can go for the higher factorial, factorize it till the next higher factorial, and then simplify it by taking the common factor out. Am I clear?
Yes, sir.
So that way, this will be 8 into 7 into 6 factorial, 6 factorial minus 6 factorial into 3 factorial. Is it alright?
Yes, sir.
And from now, from this and then this, we can see the factorial 6 and factorial 6 are common. We will take it out. So this becomes factorial 6 out common. Then inside we have here 8 into 7, we will say 56. And then here we are left with only factorial 3. Factorial 3 means 3 into 2 into 1. And the product of this will come 6. And therefore this becomes 6 factorial into 50. Right? Now 6 factorial is equal to how much? 720. 720 into 50. Right? How much? 36,000. So this is the total number of ways in which when we write, we will never find the vowels together. Is this clear?
Yes, sir.
This part was clear yesterday also. Now we are only left with the vowels occupied odd places. Vowels occupy odd places. Now here you need to be a little careful because here we need a trick. Vowels occupy odd places. First of all, how many letters do we have? 8 letters. So we need 8 spaces first. 1, 2, 3, 4, 5, 6, 7, 8. We have these 8 spaces, right?
Yes, sir.
Now, according to the instruction of this question, the vowel has to occupy odd places. That means the places that is going to be occupied by the vowels are this, 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 and this. These are the 4 places going to be occupied because there are 8 letters in the word daughter. Right?
Yes, sir.
So when we are marking the odd places, we got how many odd places?
4.
4 odd places. We have 4 odd places to be filled in with vowels. With vowels. But how many vowels do you have?
3.
It's a big question now. We are in problem. Because if we start the way we are doing, then we will have 3 vowels for the first position, we will have 2 vowels for the second position, we will have 1 vowel for this one position, and then there will be no vowel left for this position. What are we going to do? Are you getting the difficulty?
Yes, sir.
So there are situations, sometimes you will come across this kind of difficulty, where you don't have enough number of things to be placed in the given places. You do not have enough number of things to be placed in the given places. Right?
Yes, sir.
In that case, we will go for the another method of calculating the permutation, which we have done, and that is by using the formula of NPR. That NPR will here help us.
Yes, sir.
Is this okay?
Yes, sir.
In NPR, what happens is, you know the meaning of this NPR is n factorial divided by n minus r factorial, where n is greater than or it can be also equal to r. So, where n is greater than or equal to r. That means this r is mostly less than n, but it can also be sometime equal to n. But this r can never be greater than n. Is this okay?
Yes, sir.
Now the situation is we have only 3 letters and there are 4 spaces to be filled. We were not able to do it by using the principle of counting. We could not do it by using the principle of counting. In that case, we are using this formula, and for using this formula, you are completely free because now whichever number is higher can be taken as n. Whichever number is, whether it's the number of the number of letters or maybe the number of spaces available. Whichever of these two is higher will be taken as the value of your n, and the other will become r. And that's how we will be able to sort out this problem.
Yes, sir.
Is it understood?
Yes,
So
sir.
in this case, for the odd number, for the vowels to be placed at the odd places, because there are 4 spaces and there are 3 letters, the number of spaces is more. So that will be taken as the value of n. So this will become 4PR. This is the one thing that you have to remember.
Yes, sir.
Another trick is, in such cases where you have to talk about the odd or the even places, right?
Yes, sir.
After you have placed this item in the odd places, now you are left with even places. Now you are left with even places. Now whatever number of things you have, the number of place that is available will be simply increased by 1. This thing you have to remember. Here we are not going to see that how many letters we have. Letter we have enough. Letter we have 5. Letter we have 5. And here the spaces we have 1, 2, 3, 4. Here also the number of spaces less. Number of spaces less. Is it okay?
Yes, sir.
Now please keep that in mind that in such case here the number of place for the vowel, we did not do anything with the number of place. We kept as it is only. And whichever of the two, either the number of place or the number of letter, whichever is more, we have taken it as the value of n. We took it as the value of n. And the smaller number we have taken as r. Now when we talk about the even place, when we talk about the consonant, now we are going to place the consonant. in the remaining places. Am I understood?
Yes, sir.
Then what we will do here is, we will increase the number of places by 1. In any situation, you will increase the number of places by 1. So then, though you have 1, 2, 3, 4 places, how many places will you assume?
5.
For you, there will be 5 spaces. And then how many letters you have? 5.
5.
So the consonants can be arranged in factorial 5 ways. Or if you are writing that also in terms of NPL, we can continue that in terms of NPL, and then in that case we will write this as 5P5. 5P5. Because this is same as your factorial 5. This is same as factorial 5. When you calculate, you will find that this will give you the same value same as the factorial 5. Because one we are writing in terms of NPR, and other if we write in terms of principle of counting, it might create some kind of confusion. So let us have it in the same manner.
Yes, sir.
Is this very clear?
Yes, sir.
And this will give you the total number of ways in which we can have the vowels occupying the odd place. Is it very clear?
Yes, sir.
Thank you. Alright. This question is, in how many ways can 5 boys and 5 girls be seated in a row? Now the situation is, so that no 2 girls sit together. No 2 girls sit together. That means they are going to sit alternate.
Yes, sir.
They are going to sit alternate. The moment you said they are going to sit alternate, I will take this question as the previous question. Odd, even what? Alternate only. That is also alternate. So this question matches with that previous question.
Yes, sir.
So in this question also we are going to do the same activity. We will first of all fix the position of 1, maybe the boy, right? And then we will fix the position for the girls. Is it okay?
Yes, sir.
First we will fix the position of the boys. And after fixing the position of the boys, when I do the calculation for the girls, then I will increase the number of places by 1.
Yes, sir.
Are you getting me?
Yes, sir.
Now when I am placing the boys, if I don't have enough of space, I will go to NPR. If I have enough space, I will go for principle of counting.
Yes, sir.
So try to see the difference. That's why I am having these 2 portions very close to each other. These portions are not given in your book, right? This is just to show you the actual difference between the 2 very close questions. So here, this question number A answer, solution. No 2 girls sit together. Total how many are there? 10. Total. Don't be so selfish. Don't see only yourself. There are boys also. 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 seats available for 5 boys and for 5 girls. According to the instruction, no 2 girls sit together. That means first of all I will place the boys.
Yes, sir.
Only after placing the boys, if I keep the girls, then I will make sure that they are not together. No? Otherwise, if they are given opportunity to sit first, then they will definitely sit together.
Yes, sir.
Right? And then the answer will become wrong. So first of all, we are placing the boys. Put the boys here, put the boys here, put the boys, and then boys. Understood?
Yes, sir.
The boys are placed in such a way so that the girls will not be able to sit together. Is this okay?
Yes, sir.
So in between the 2 girls, there should be a boy. So we have placed the boys, and for boys, there are 5 boys, and we have enough number of seats. No need of going for the NPR. We can do it by principle of counting. So the number of ways the boys can be seated is factorial 5. Is this okay?
Yes, sir.
Now how many girls we have?
5.
5. And for the number of seats, what do we do now? We increase the number of seats by 1. So though there are 5 seats available, but the logic is that they should never be together. But that means also we can understand this as they have to be in between the 2 boys. Is this okay?
Yes, sir.
So we will have 1 extra seat, that is total number of seats will become 6, and then there are 5 girls. Okay, so they can be arranged in factorial 6P5. Is it okay?
Yes, sir.
And this will give you the total number of ways in which the girls will never be together. If you can simplify, you will simplify this as factorial 5 as it is just now, we will keep it. This will become factorial 6 divided by 6 minus 5 factorial. 5 factorial, and this will become equal to 5 factorial into 6 factorial ultimately, because the denominator is 1 factorial, and you know 1 factorial, the value is equal to 1 only. So just multiply and you will get the answer.
Yes, sir.
Is it clear?
Yes, sir.
The next part of this question is, before we go to this next part, we will come to this part, C part, right? First of all, we are doing this C part. In the C part, all the girls together and all the boys together. Okay, how we are going to do it? There are total 10 seats available, right?
Yes, sir.
10 of them, so 10 seats. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right?
Yes,
And this
sir.
time you are all given opportunity to sit together. So this is one of the elements: boys, 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 and then boys. All the 5 boys are seated together.
Yes, sir.
Then all the girls are seated together. Girls, 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 and then girls. So there are 5 places for 5 boys, so they are sitting in factorial 5 ways.
Yes,
The
sir.
boys will sit in factorial 5
5
ways. Factorial 5. The girls are also 5 in number. They also have 5 places, so they will also sit in factorial 5 ways. Factorial 5 ways. Is this done?
Yes, sir.
Is this the right answer?
Yes.
What happened? Is this the end of the question? Then what more we need to do? We will multiply. Of course we will multiply, but then that is not my task. That will be your part. You will do the calculation. Of course, if you demand, I can do the calculation. The calculation is not very difficult. Okay. Anyway, I will show you the calculation, but this is not the end of the question. This is just one of the arrangements that we can have the boys here, and then we can have the girls here. And that way, this is the number of ways they can be seated. But there is another possibility that they can sit here and then they can sit there also.
Yes, sir.
That means now when they sit here, then again they can sit in factorial 5 ways, and when they sit here, then they can also sit again in factorial 5 ways. That means this is going to be increased by twice. So this will become the actual calculation.
Yes, sir.
Is it okay?
Yes, sir.
Now if you want me to calculate, this is 2 factorial 5 means 5 for the 20, 60, and then 120. So this is 120 into 120. This is 2 into 14400, and then this is 28800. This many number of ways they can sit. Is it clear?
Yes, sir.
Thank you. Now we are going to do this B. But before we go to B directly, I want you to go through these 2 statements and see what is the difference between these 2 statements. A says no 2 girls sit together, and here say all the girls are never together. What is the difference between these 2 statements? No 2 girls sit together. All the girls are never together. Do you find any difference? No.
Yes, sir.
Here it says very clearly that no 2 girls can sit together. But here say all the girls cannot sit together. How many girls are there? 5. According to this statement, 2 girls can sit together.
Yes, sir.
3 girls can sit together.
Yes, sir.
4 girls can sit together.
Yes, sir.
All should not be together.
Yes, sir.
That is the difference.
Yes, sir.
Is this okay?
Yes, sir.
Okay, now, answer of this question is very easy actually. We have already done this part. That is why I separated it. All the girls are never together. Right? And before we find the answer of this question, if we can know that in how many different ways you can have all the girls together, if you can find out that, you will get the answer of this question very easily then. From the total number of arrangements, total how many are there? 10. So first of all, we need to know the total number of arrangements. From the total number of arrangements, we will find out the number of ways in which the girls can all sit together. Girls can sit together. Vowels together. Girls together. What is this? Same type of thing. So whenever you see the word together, you put them in one box. Whenever you see them together, put them in one box. We put the vowels in one box. Now this time girls, we wants to be together. So put them in one box. Is this okay?
Yes, sir.
So the 5 girls are kept together in a box, right? And they are denoted by one letter. Same like previous question. We will mark it as X. And after this, now you have how many boys? 5 boys. For 1, 2, 3, 4, 5 boys.
Yes, sir.
So 1, 2, 3, 4, 5 boys. The boys I am representing with the number. Now total altogether, how many numbers we have? 6. Now if you take these 6 together, you will find, write this 6 number in any way, you will find that this is always together. Because you are writing X at one place only.
Yes.
And X is representing all the girls. Because all the girls are in box X. So wherever you take, they are always together. So we are able to find the number of ways in which the girls can be together.
Yes, sir.
And that is 6 factorial. 6 factorial. Again, inside the box, among themselves also they can change their position.
Yes, sir.
So further they can sit again in factorial 5 ways. So the total number of ways in which the girls can be seated together will become the product of factorial 6 and factorial 5. Am I understood?
Yes, sir.
So in this many number of ways, the girls will be sitting together. Now, we don't want the girls to sit together according to this statement. So that answer will be separated from the total.
Yes, sir.
Am I clear?
Yes, sir.
So we can say the number of ways in which girls never together. To find out this, what are we doing first of all? Is finding the total number of ways. Finding the total number of ways in which all of them can be arranged. All the boys and girls can be arranged. The total number of ways, the total number of elements, the total number of arrangements for all the boys and girls will be factorial 10. Now then we are calculating in how many ways the girls can be always together. We have already discussed, right?
Yes, sir.
So the number of arrangement keeping the girls together. Keeping girls together will become how much? Factorial 6 into factorial 5. And now, if this part, because here this is the number of elements in which the girls are always together. So this will be separated from the total number of elements. We will get the total number of elements where the girls are never together. And therefore, we can write this as factorial 10 minus factorial 6 into factorial 5.